On second thought, after that last video, I realized that since some of the exercises it came up with were pretty fundamental, they were pretty straightforward, and also because I asked a different question than I asked before. So in the last video, I said, just give me practice questions. And maybe it came up with some basic stuff as a result of that. I think I'm going to go back and ask it for actual programming exercises, and then maybe argue with it a little bit until it gives me something a bit more substantial to work on. All right, so I just learned about pointers in C. Can you generate 3 programming exercises involving pointers? I don't know about arrays or strings or linked lists or dynamic memory, so don't even think about including those concepts in the exercises. All right. Of course! So enthusiastic. Here are 3 programming exercises involving pointers that don't involve arrays, strings, linked lists, or dynamic memory. Okay. Maybe I'll just be selective here because maybe these overlap with last time. So I notice exercise 1 is swap 2 numbers. Well, we just did that, so we'll skip that one. Exercise 2, calculate factorial. Okay, ChatGPT just loves factorials. Write a C program that calculates the factorial of a given integer using a pointer. Okay, that seems like we're just dressing up the factorial exercise from earlier with sort of needless use of pointers. The program should take an integer input from the user and then use a pointer to calculate and display the factorial of that number. I think it's got an idea here, but it's not coming across very well. Exercise 3, modify variable through pointer. Write a C program that defines an integer variable and a pointer to that variable. The program should take an integer input from the user and assign it to the variable using the pointer. Okay, this seems a bit too straightforward as well. This seems like a thinly disguised version of the exercises we did in the last video. So I'm going to focus on exercise 2. I want to do exercise 2, but I don't quite know what it means by this. Use a pointer to calculate the and display the factorial of the number. I'm going to ask it for clarification. In exercise 2, what do you mean by use a pointer? Okay, and then I'm also going to say, because we've noticed in the past that when you ask ChatGPT for clarification, it gets too eager and it just gives you the solution. So don't give me the solution to the exercise. Okay. Apologies for any... Okay, so ChatGPT is good at being enthusiastic, loving factorials, and apologizing. Those are 3 strengths it definitely has. In exercise 2, when I mentioned use a pointer, I meant that you should use a pointer variable to perform the calculations involved in computing the factorial of the given number. The pointer can be utilized, okay, the pointer can be used to hold temporary values and perform the necessary operations as part of the factorial calculation process. I might use a pointer if I were calling functions, but it doesn't really make that much sense to use pointers just inside of main. Do you expect my solution to involve functions? If so, can you give me the function signatures? That might give me enough of a hint of what it wants. I'm going to say, just a reminder, don't give me the solution to the exercise. Certainly. If you're considering, okay, so let's take a look. I think I've confused it. If you're considering using functions, here are some function signatures. Yeah, okay. Neither of those function signatures involve pointers. Do you want to try again? Okay, yes, apologizing, fine. All right. Okay, I think I can work with this. So you're right, the function signatures I provided don't involve pointers. I think the problem with ChatGPT is that it has a very short memory, so it'll answer your question, but it doesn't really remember what you asked a few minutes ago, even if you scroll up in the same chat in every case. But whatever. Since you're focusing on pointers, here are some function signatures that use pointers for exercise 2. Okay, so I think I have enough to actually do the exercise now, and for the exercise to actually be meaningful. So I'm going to go grab the prompt for the exercise itself, and I'll bring that back over here. There we go. And then I'm going to go grab those function signatures and try and find a way of incorporating those function signatures into this exercise description. Okay, so I'll go down here, and then here are my two function signatures. So I've got one called calculate factorial, and I've got one called display factorial, which is sort of weird, but fair enough. It's pretty clear what it's supposed to do, and just in case it weren't, I will take the little descriptions that it provided as well and paste them before the function. These are not formal descriptions. We saw in an earlier video what happens if I ask ChatGPT to give me a formal function description. It generates something very similar to what you've seen in the examples I've done in lectures and on assignments and midterm questions and things. So it understands what a formal description is, but by default it doesn't generate that. Okay, and then we'll take this. Now, the display factorial function does seem a little bit trivial, so I'm going to have to just make up some behavior for it that makes sense to try and give it some meaningful use. All right, so I think the prompt is write a C program that calculates the factorial of a given integer using a pointer. The program should take an integer input from the user. Now, this is something that in previous weeks I have refused to do. I've told ChatGPT to give me a different exercise every time it asks me for this. And the reason was because in this course, in this version of the course, we don't cover integer input until we've seen pointers, because the function that we use, the scanf function, requires the use of pointers. But we know pointers now, so I guess I have no excuse. So what I'll do is I'll start by writing the main function. It'll say enter a number, enter an integer. All right. I remember from a previous exercise that ChatGPT would rather that I catch the case where the value for which I'm trying to compute the factorial is invalid. So I'm going to try and monitor whether the user enters a positive integer or not. I don't want to try and compute the factorial of a negative number. Okay, so enter an integer. I'll make an integer value called n, and then I will use the scanf function to read one int. Okay, now recall that when you use scanf, you tell it what to read by using a formatting specifier just like printf, but then you provide, as in the list after the format string, you have to provide pointers to the things that you're reading into, unlike in printf where you do not use the ampersand. I also want to insulate against the case where the user doesn't enter anything. So I'm going to use the return value of scanf to do that. So recall that here I've asked scanf to read one thing, an integer. And scanf is a function and it has a return value. And for our purposes at the moment, when we're reading integers, scanf's return value is going to be the number of things that it successfully read. And so I expect that scanf will return 1 if it read something successfully. So if it doesn't return 1, so its return code could be 0. There are strange cases where it could return a negative, well, it could return something that isn't 1 or 0. But if it returns 1, then it succeeded. So if it doesn't return 1, then it failed. And I'm just going to write, you didn't enter an integer. Goodbye. And then I will exit the program. So return 1 is a way of exiting. Well, it returns from the main function because I'm in the main function here. And we know that when main ends, the program ends too. So return 1 is a way of exiting the program immediately at this moment. So now I know on line 31 that n is going to be filled with an integer value that the user entered. Now, on the other hand, if n is less than 0, then I can't compute the factorial. So I will write... I can't compute factorials of values less than 0. And you can look up what the factorial of a value less than 0 is, but it's not something we want to do today. Okay, so I'll exit the program again in that case. And now I've got to figure out a way of using these functions that ChatGPT suggested. Now, these, I would not generally write a program this way. And as you saw when I was arguing with ChatGPT about the exercise itself seemed a bit vacuous. It seemed like I don't need pointers to compute factorials. It seemed like a contrived question. Now, fair enough. First off, it's hard writing programming practice questions, so we should cut ChatGPT some slack on that front. But also, even if I think the exercise is ridiculous or it's stupid or something, I still should be able to do the exercise. And it is sort of useful. It's a nice challenge to do exercises that other people came up with, even if you think they're ridiculous, just to make sure you can still operate under some different mode of thinking. So I have two functions that it made up for me called calculate factorial and display factorial. The naming convention it used for the functions I wouldn't wouldn't use. I'd probably call these functions calculate factorial with an underscore. ChatGPT seems to like to name functions in a sort of Java-style way. And then it takes as an argument the value of n, which is what so n factorial is what I'm trying to compute. And then I'm interpreting this to be a place to put the result. Now, normally, if you want a function to compute factorials, you should have it return a value. This is actually not good style in my mind, but whatever, it's a contrived exercise. And then I've got this function display factorial that takes a pointer, so it takes a constant pointer, which we already know we can set a variable to be constant, which means nobody's allowed to modify it. But it makes sense our display factorial function wouldn't want to modify the thing that you gave it, it just wants to display it. And so it's going to take a pointer to an integer value containing a factorial and then print it out. I'm going to make one adjustment to the signature here. I'm going to write the type of the pointer as putting the star next to int. We already know that where you put that space is nobody's business, so you're allowed to write the type like this if you want to, but I like putting the star up against the word int to make it really obvious to anybody reading that the star is part of the type. It's not part of the variable. The variable is a pointer, but that's because it's of a pointer type. Okay, so I guess I'm going to write main to call those two functions. So I'm going to make a variable to store the result, to store the factorial of n. I'm going to call that int n factorial. And then I'm going to call the function, what was it called? Calculate factorial? Okay, I'll just copy that name. I'm going to call the calculate factorial function. It's going to take two arguments, an integer value of n and a pointer to somewhere to put the result. Okay, so I'll pass in the value of n that the user gave me, and then I will pass in a pointer to my variable n factorial. All right, and then I will call the display factorial function. Display factorial, and I'll pass it, all it's taking is a pointer to the finished factorial value. So I guess I'm going to pass it again the address of, or an arrow pointing at n factorial, my variable. Okay, so I think that's it. So I guess what I now have to do is write those two functions. Okay, I'll start writing the calculate factorial function. There are a lot of ways you could do this. So one way you could do it is you could make a variable to store the result yourself. So maybe I'll call it fact. I could make a variable to store the factorial, and then down at the very end, I could say star result equals fact. So I could just use a regular int variable to compute my factorial and then work with the pointer at the end. But whatever, it's a pointer exercise. I'm going to try and use this pointer all the way through. So if I'm going to use this pointer value result to do arithmetic, every time I refer to result and I want to store a number into the thing it points to, I have to say star result. Other than that, I suspect that we're going to end up with pretty much exactly the same factorial code we've written now several times. So just to remind ourselves, if I want to compute 5 factorial, well, that's 1 times 2 times 3 times 4 times 5. And there are lots of ways of doing this. By now, we've even seen in the other videos, the actual lecture videos, we've even seen a recursive way of doing this. But I've done it the same way in the other videos in this series of practice exercises, so I'm going to do it the same way that I've done it there in this example, which is I'm going to start by setting the result to 1, and then I'm going to count off 2, 3, 4, 5, whatever, up to the value of n. So I start a counter at 2, and then I've been using a while loop for this, so while counter is less than or equal to n, keep going, and I'll say star result equals star result, all multiplied by the counter. Because these star symbols could get confusing, I'm going to put this in brackets to make it obvious here that this star isn't multiplication, it's me following an arrow. And then counter equals counter plus 1. All right, so I've got that. And now, let's see, I guess I don't need to return anything at the end. This actually might be the end of the function. So because the function is not returning a value, again, not good style in general, but this is a contrived exercise. Because the function's not returning a value, I think I'm actually now done. I think I just have to leave this here. I'll try compiling it to make sure I haven't forgotten something obvious. Okay, yeah, so I haven't defined the display factorial function, fair enough. Okay, so I'll do that now. It doesn't look like very much is needed here. I just say the factorial is, and then there's the answer. And I print out star factorial because my variable is of type const int star, which, I mean, that's going to be a pointer to an int. So I will follow the arrow from there to print out the value, and then I will try compiling. Okay, so this time it compiled. We'll try running it. We've been always working with 5 factorial as our basic test case. So the factorial is 120. That doesn't surprise me. That's what I expected. Let's try 4 factorial. That's 24. Let's try 10 factorial. Maybe we've all memorized 10 factorial by now. There it is. Let's test out our error handling. So I actually think this is enough test cases, especially since we've written this code over and over again. I think this is enough test cases to justify that the calculate factorial function and display factorial function seem to be working. But there's some other code that I wrote that I should also test. So what happens if I enter some junk? It does say, it is able to catch that and say, sorry, you didn't enter a number, goodbye. What happens if I enter a negative number? Then it says, I can't compute factorials of values less than 0. And actually, it does say less than 0. So what happens if I try and compute the factorial of 0? Okay, wait, that's wrong. 0 factorial, if 0 factorial exists, it's supposed to be 0. So what do I do here? Okay, one option is I could just say, if you give me a 0, we're done. So I could say, values less than or equal to 0. So I'll show off that solution. This is me basically passing the buck and saying, I don't want to deal with this, so sorry, you have to go do that yourself. Or I could maybe argue that 0 factorial does exist, and whether or not you want to do this comes down to a lot of questions, like when you were taught what factorials are, what would you assume? As usual, if this were an actual exam question or something, you'd be told what to do in this case. But I think we should try that out. So my argument is, I guess, that if I'm talking about like 3 factorial, that's the product of every integer up to and including 3. And you could make the argument that, okay, so 1 factorial is just equal to 1, and then 0 factorial is equal to, well, the product of nothing. Okay, so what is that? Well, there are a few ways we could treat this. We could argue that the product of nothing is actually still equal to 1, which is what my program was doing a minute ago. But we could also argue that the product of nothing is equal to 0. Now, as it turns out, I actually tend to come down on the side of 0 factorial equals 1, but that's a story for a different time. For the sake of having something interesting to do with this exercise, I'm going to say, suppose that we think that the factorial of 0 actually is 0. So I don't actually think that, but suppose that we do. Well, how about this? What I could do is go up here to my compute factorial function, and I could just say, look, if n is equal to 0, then let's just say that the factorial, so my star result, equals 0, and now end the function immediately. Don't go and do the calculation. Instead, just stop. Because the function has return type void, I can write this return statement with no expression afterwards, because obviously when I'm returning void, there's no data to be sent back. So we'll try this out. Enter an integer, 0, the factorial is 0. Okay, now you might be asking, why do I think that the factorial of 0 actually should be 1? And that comes down to what we interpret the product of 0 things to be. And that's a whole different question. Come talk to me in the office hours about that. Okay, so there's my solution to this. I think we're going to leave, let's go back to the version where 0 factorial equals 1, because that's, from at least to my taste, a little bit more correct mathematically. Okay, so I enter the integer 0, the factorial is apparently 1. It does do it. Okay, so what I want to try out now at the end is, because I had to argue with ChatGPT a little bit about what the answer was, I'm sort of interested to know what it thinks the answer is. Could you now show me the solution to exercise 2 using the functions that you described? I have to be careful what I ask it to do, because I think it might get confused otherwise. Of course, here's a solution using the function signatures that were provided earlier. I'm going to actually copy this, and let's go bring it in to Jupyter Hub. For the sake of getting a split screen view, I'll just step on this code here. Okay, so here's ChatGPT's solution over on the right, and there's my solution over on the left. Let's compare them. Now, ChatGPT's solution hasn't seemed to use any comments, but I don't know. Can we blame it? We didn't ask it for well-commented code, I guess. Okay, so in main it says enter an integer. Okay, sure enough. And then the scanf call that ChatGPT generated doesn't check for the case where the user doesn't enter an integer. I have half a mind to give it a hard time about this. And then in the calculate factorial function, it is doing something pretty similar to the loop that I'm using. So it's calling its counter variable I, and it's starting the counter at 1, which maybe is doing a bit of extra work, but actually isn't a bug. That's just a little bit of extra work. And then at the end, it copies the result into this int variable, this pointer that I passed in, which is neat because that is the alternative option that I suggested when I was writing the code. And then down here in display factorial, it does pretty much the same thing that I did. Okay, so it generates pretty similar code, although it does it in a different order. I like writing my functions before main. ChatGPT likes to generate function declarations, then main, and then down here, give the definitions of functions. So one thing remains, which is that ChatGPT didn't do a very good job of error handling. So if I pass in a number like 0 or -1, it's not going to catch that, and I'm going to give ChatGPT a hard time about that. In your solution, what happens if the user enters non-numeric data, and I'm going to give it an example like that, or a negative value? It's probably going to apologize. Oh, it didn't. Well, that's good. It's good to have some confidence. There's nothing wrong with not knowing what to do because the exercise was unclear. I can say that because, I didn't write this exercise, so I don't feel bad about that. In the solution, the program does not handle cases where the user enters non-numeric data or a negative value. And then it does concede input validation is an important aspect of yes, okay, we know. So to handle these cases, and I think then it's going to... it looks like it's going to provide me an alternative. So let's copy this and take a look at it. And I'm going to bring this back over here so we can look at it without it getting squashed. So it's now, this is just the new main function. Whoops, I guess I have to, okay, so I'm going to paste over the old main function. And it says enter a positive integer. And this is neat because it previously just said enter an integer. Because it's now going to verify what it gets, it's trying to tell the user, hey, don't waste my time entering something other than a positive integer. And then it's created this rather weird looking loop, which I'm going to need a minute to stare at actually, because there are a couple of aspects to it that are rather unconventional. So it looks to me as if what it's doing is it's calling scanf, and it's doing the same thing I was doing in my code where it asks if scanf's return value is equal to 1. And so it first asks scanf to read a value, and then if the result comes back as a 1 and the number that was read is greater than or equal to 0, then there's a valid input. And so this is a weird way to write this logic, but this break statement here is a way of it telling, it's a way of it ending the loop immediately. The point of this weird while loop is to keep asking the user for input until they generate valid input. And if they generate valid input, then that loop can end. And so the break statement just says end the loop immediately, go down to line 20. If we don't get inside this if, it's because there was something wrong with the input value. And so it prints out, sorry, that was wrong, try again, enter a positive integer. I'd rather not go into too much detail about this, but basically the point of this loop is to expunge any other input that was lodged in the input buffer. So if the user enters a bunch of junk, so if the user enters, let's just try running this. If the user enters ASDF or something, there could be a bunch of text stuck in the input buffer that we then have to get rid of before we can read the next number. So we'll try this out. Let's enter 5, the factorial is 120. We'll enter 4, or 3, the factorial is 6. Let's try entering negative 23, invalid input, try again. Okay, we'll enter negative 24, still invalid. Let's enter 5. Now the factorial is 120. Now suppose I enter some junk. Here, it ignores the junk and says that's not going to work, and then I enter a value and it computes the factorial. Now this loop that keeps calling getChar, what it's doing is trying to insulate against a situation like, suppose I enter some junk and then a number buried inside of more junk. So somewhere in this line of input, there is a sequence of digits that you could parse as a number. But there's a question of, does the user actually want this factorial computed, or is this just part of the junk that they're giving me instead of a number? And what ChatGPT has generated is this clever little loop here, although this isn't the way I would write such a loop because it's a bit cryptic. This loop is saying, look, if scanf couldn't make progress on this line of input, then just read all the characters in the line and skip to the next line. So you can see it's going to call getchar until the result is a new line. In other words, just skip over anything else in the same line of this user's input. I'm wondering if there is still a case that might break this. So, okay, I'm still running the program here. Let's try this situation. Suppose I enter some junk beginning with a digit. And we can see here that it does get fooled into thinking that I gave it the number 4 and then some garbage. Now, to be fair to ChatGPT, the solution it's come up with is actually quite a bit more robust than my solution. My solution only ignores the junk and then exits. It doesn't give the user a second chance, whereas ChatGPT is trying to give the user repeated chances to get the input right. Instead of just quitting the first time that it notices a problem. And although I was able to fool it with this, mine should also have that problem. So if I enter some junk, the program quits. But if I enter junk, if I enter an integer followed by junk, it does read the integer and then ignores the junk and prints out the factorial of the integer at the beginning. So my program isn't any more robust than ChatGPT's, and something like what ChatGPT came up with is a little bit more complicated than we would expect in a course like this, which is why I didn't write this. I'm really interested, though, to see whether ChatGPT can recover from this error here. I'm going to ask it, although I will acknowledge that actually I don't want to write the code to fix that error. I'm just interested in seeing what ChatGPT can do. That looks good. I want to give it some positive reinforcement. That looks good. But what happens if the user enters an invalid sequence like 3ABC, which begins with some digits and contains erroneous non-numerical data afterwards? I feel like that's a pretty concise description. You're right. The solution I provided still needs improvement. I'm actually really interested to know what it comes up with here. So it looks like it's going to generate me a new main function that gets around that problem. Okay, yeah, this is pretty complicated. So what it's doing, I'm going to give a high-level description. We have not seen much of what we need to understand this solution. But basically what it's doing here, this is an array, what it's going to do is it's going to read all of the user's input into an array. So basically keep all of the user's input. And then it's going to use this is a loop, this is an if statement that's actually retrieving characters from the user. It's then going to use this loop here to try and verify that what the user entered consists only of digits. So you can see it's asking if a digit was read and then counting how many digits were read, and nothing else. If it reads anything else, any junk, then it's going to give up and try again and ask the user to enter stuff again. If it determines that all that was read was digits, then it's going to try and actually interpret that as an integer. But this is pretty complicated. You probably would not want to write, you probably wouldn't end up writing code like this until the very end of this course. I'm interested, though, to see that ChatGPT, for all of its other faults, was able to walk me all the way through that. As every error I pointed out, it was able to fix. So that was pretty interesting.